Good afternoon. This is our last video lesson for minerals for the Earth Science class. So the last of the important material in that narrated PowerPoint would be the classes of silicate minerals. So in a previous video lesson, we discussed the classes of minerals in general, and the last one we looked at were silicates, and I had mentioned that silicates they're abundant. They're making up 95% of all rocks on this planet. The silicates are important, and there's different types. So we have different classes of silicates. Now I don't have all of, and I'm trying to move around here and get this to where we have the least light glare possible on the board, by the way. I don't have all, oh, I forgot to put the last one up. Well, we'll get to it in a minute. I don't have all of the classes of silicates up here because not all of them are going to be on your exam. The ones that are going to be on your exam are on the board. We'll begin with number one, isolated tetrahedra. So that triangle there with the dashed lines coming from each three corners and meeting in the center, remember that is representing our silicate tetrahedra, SiO4 with a -4 charge. Each of the three corners represents an oxygen atom where the dashed lines come together in the back as the oxygen atom we don't see. And then there is a small silica atom inside. Okay, so the isolated tetrahedra are drawn as one tetrahedra. Why? Because no oxygen atoms are going to be shared by the individual tetrahedra here. Examples of minerals that are isolated tetrahedra would be garnets, which make nice jewelry, and olivine, which is the dominant mineral in the mantle. All right, scooting over, and nope, yeah, okay, that's a little bit better on the light glare. Okay, so our second are the single chain silicates. So you see here that you have these tetrahedra sharing two of its four oxygen atoms. And I could have drawn this longer, but you know, I have limited board space, but they're just going to continue to the right and to the left, and they're going to form these long continuous chains. And the example that people in lab would see is something called augite, which is a mafic silicate mineral. All right, let's see how to get the least amount of glare to look at our double chain silicates. And I think it's gonna have to be like that there. Okay, so double chain silicates. Imagine two of these single chains kind of joining in the middle. So you can tell from the drawing here that each tetrahedra is sharing either two oxygen atoms, the ones on the outside share two, or three oxygen atoms, the ones on the inside share three. Examples of minerals we might look at in lab would be hornblende. The E is silent. Hornblende is also a mafic silicate mineral. Okay, the sheet silicate. Now, how's our glare here? It's not that bad. Oh, I didn't write the example down. Actually, we're going to take a minute here, and I'm going to add a couple of things. I'm going to set my camera down. We need to add a couple of things here. I need to add an example of sheet silicates and add one more type of silicate. Okay, back to the lesson. So, add a couple things there. All right, I think we don't have much glare on our sheet silicates. So the sheet silicates, I know this drawing isn't pretty. There are better versions of this drawing in the PowerPoint. This is what I could do on the fly, not being an artist. So in the case of the sheet silicates, you have a bunch of tetrahedra sharing three oxygen atoms, basically the three that are on the bottom. And they can build out these extensive, thin, flexible sheets. So up here in blue, our example of sheet silicates would be the micas. muscovite mica and biotite mica. In class, I will hold these up for you guys to look at. We can't pass the minerals around anymore, I guess, until the pandemic is over. All right, one last class of silicate minerals, framework silicates. What happens here is that all 4 of those oxygen atoms are shared. I'm not even going to attempt to draw this. I wouldn't know how. There are some drawings in the PowerPoint. Even the artist can't do a very good job. It's something you just kind of have to think about. So it's going to build a 3-dimensional framework. The important thing here for your exam would be to know a couple of examples of framework silicates. And the best examples would be quartz and feldspar. Framework silicates, but also are 2 dominant minerals in the continental crust. All right, that will do it for minerals. Peace out.